Okay, I think we'll get started. Welcome everyone, and hope you're having a great Data Nerd Days. This talk is going to be about optimizing Gatsby build performance with observability. So let's get started. As you can see, that is not me. I'd just like to give a shout out to Daniel Kim, who is my partner in this project and my incomparable helper on this project. So thank you, Daniel. This is me. My name is Rory Douglas. I'm a software engineer here at New Relic. I've been with New Relic about 3 years, but just new to software engineering in the last 6 months. So firstly, for those who don't know, I'll give a brief explanation of what Gatsby.js actually is. So it's a static site generator. It's based in React, and it's powered by GraphQL. And what it basically means is it allows you to get all of your data from any place that you want, from like CMSs, from WordPress, from third-party APIs, from MDX files, from basically anywhere. It puts it all together into a GraphQL layer, compiles your data, and your React components to static assets, so you can deploy them to a CDN of your choice. So static assets does not necessarily mean that it's a static website. So what Gatsby uses and what's a function of React is something called hydration. So hydration is the process of using client-side JavaScript to add application state and interactivity in server-side rendered HTML. So that basically means all of the processing is done client-side, so it means a lot less HTTP requests when a user is accessing your site, which is great because that makes the user experience time a lot, their wait time a lot smaller for page loads and things like that. So it bundles all these together into a package and then allows you to host them for a much smoother user experience. So today we're going to talk about specifically builds with Gatsby. So what actually happens during the build process? The node objects are sourced from plugin data sources. So Gatsby uses lots of different plugins. It actually has a really rich community and ecosystem. A lot of people contributing great plugins to pull data from lots of different places and pull them into Gatsby to create static sites. So you define the data sources and the plugins in your Gatsby configuration file, and you define what you want to do with them in your Gatsby node.js. So Gatsby then infers a schema from these node objects. Pages are then created based on JavaScript components in your site or in installed themes. And then GraphQL queries are used to extract and run to provide data for all the pages. So everything is compiled and put into GraphQL and allows you to easily query that data and consistently query that data for different pages. Static files are then created and bundled in the public directory. So the build includes minified files, transformed images, JSON files with information and data for each page, and static HTML for each page. So it's basically everything your site needs in order to present content to the end user. So when we build small websites, so like say you had a small blog, less than 50 pages, the build times are pretty manageable. When you're developing, obviously, you want your build time to be small so that you can test out changes. But that's not always the case. So for example, our doc site, and the team I'm on actually looks after the documentation site, the developer site, and the open source site. So all these sites are powered by Gatsby. And at the moment, we have 5 web properties, so 5 separate sites with 30 plus content updates per day, 325,000 sessions per month, 700,000 page views per month, and over 8,000 markdown files, which is what contains all of our content for the documentation. So it's a pretty big site. We also use over 100 plugins as part of the building of the sites. So when I started, the average build time for the New Relic doc site specifically was a very long time. And that means whenever you want to make a change as a developer, particularly, if you're making changes to Gatsby node, Gatsby clears the cache. So in some instances, if you're just making changes to content, Gatsby will save the cache so that you don't have to create that content again on a separate build. But unfortunately, as a developer, when we're making changes to Gatsby node and its plugins, this is the time that we have to wait in order to see our changes be built and be able to look at them in a web browser. So our challenge was to try and make our site build more efficiently. And that was a focus when I started on the team. So in order to do that, we needed to be able to see exactly what the site was doing, to get visibility into it, to see what parts of it were slowing the build down and where we could make improvements. So it just so happens that New Relic is an observability platform. So it allows us to analyze, troubleshoot, and optimize our entire software stack. This also means that we could do something with Gatsby build. So what is observability? Observability is the ability to measure the internal states of a system by examining its outputs. And that basically just means you get visibility into what your software is doing at a specific time to help you troubleshoot issues or get to the root cause of issues a lot quicker. This is fine. So what we wanted to do was build a plugin to build on what Gatsby already does to collect all of that delicious data and send it to New Relic. So every build produces a lot of data, and if you build Gatsby locally, you can see all the log output in your terminal, but it doesn't always make the most sense. I mean, you see like, okay, some things were successful, some things weren't. But then if you're building in something like Netlify or Gatsby Cloud, you have to go looking for those logs and looking for the data that's contained in there to see if you can glean any information from them. So what we wanted to do was collect these logs to see how long each step was taking, to try and put together basically a proposal to see and a comparison to see how faster a build would be under certain circumstances. So for example, in our case, we wanted to move to hosting on Gatsby Cloud. So this is a perfect opportunity for us to compare our build times on our previous hosting locally and on Gatsby Cloud to see the improvements. So data by itself isn't useful. So what we need to do is to save that data so that we can compare data across different builds. And New Relic is the perfect place to do that. So we needed a solution that turned logs into structured data, gave you the ability to store and query the logs easily. So for that, we used Winston, which is a pretty popular log structuring tool. I think they have implementations for most languages. So we use Winston to basically package up the logs into JSON format and send them to New Relic to be processed and easily queryable. So this is what the raw logs look like in your terminal, and this is what is parsed and sent to New Relic. And the other good thing about this is that we can add other information to this JSON if we want. So we could say what build this is part of, what feature we had turned on at the time, etc., etc. So this is what the logs UI look like, and we'll go into that in a bit more detail when we get into the demo. But as you can see, you can very easily query for specific things and see the instances of those logs as well over time. But what if we need to drill deeper? What if we need to see what's behind those logs? So a plugin, an API is emitting those logs, and they're kind of a general sum of the entire data set for that plugin. So that plugin is doing a lot more under the surface. So how can we get more information into that? Traces is the perfect way to do that. Tracing is basically, a trace shows you the activity for an individual transaction or request as it flows through your application. So if you think of it as, you can see into the veins of your application, you can see the data that's flowing through, where it's touching, and identify any bottlenecks that may be occurring through your build. So Gatsby actually already has a really great performance tracing capability built in. So with that, you can use Open Tracing, Jaeger, or Zipkin to basically package up those traces. And with those solutions, they use a Docker container to kind of visualize the traces on your local system. But what we wanted to do was create a semi-custom offering that actually packaged up the traces and sent them to New Relic instead, directly. So yeah, they're built on Open Tracing, which is a vendor-agnostic API to help developers easily instrument tracing into their code base. Okay, so yeah, so traces will give us more information as to what exactly a plugin is doing, how often it's doing it, and things like if it's running synchronously or asynchronously, which might slow down our build. And will give us more information on how much detailed time is actually contributed by each plugin or API. So this is also a little snapshot of what the distributed tracing UI looks like, but I'll go into that in more detail in the demo as well. And it's time for the demo. So you can follow along with this at the link, which I'll put in the chat. So we basically built a website and made it as slow as we possibly could for Gatsby build. So just to kind of compare the before and after. So before we make changes and after we make changes, what do those changes do? How do they affect our build time? How do they affect different things? So if you haven't signed up for New Relic yet, you will need to do that. So you can follow the trynewrelic.com/datanerddays link and sign up. So the first thing we want to do is clone this repository. Excuse me. Apologies. So I've actually already cloned the repository. So here you can see it locally. Just 1 second, apologies. Apologies for that. A little technical hiccup with my body, which is the last thing you expect to go wrong in a demo. So basically, we want to clone this repo first. So we've already done that. So next, we'll need to go to a new Relic 1. And we want to go to API keys, which should be here up in the top right corner. If you click on your avatar and click API keys. So we'll need to copy this key. And we'll also need to grab our account ID, which is here. So because I'm a smart cookie and we don't share secrets, I've already saved these and exported them as environment variables. But you can paste yours in here when you've done that. Then the last thing we need to do, or the second last thing we need to do, is just give our site a name. This would just be the name that it appears under as an entity in New Relic 1. Okay, so next we need to just copy this. Okay, we need to install the plugin first, of course. So we just run npm install Gatsby build New Relic. And while that's installing, we need to copy this little snippet, and that will go in our Gatsby config.js. And just under here, under plugins. So it's basically the same. It's just a plugin that's being called by Gatsby, and Gatsby knows to call it just by placing it in here in the config. So all we need is the license key, account ID, and site name. This is useful for adding custom tags to your data. So if you have different builds and you're testing out different things, you can add certain flags here, and that allows you to differentiate between those different things in the New Relic UI, which is really handy. So we've called our site the Janky site, and we've tried to make it as janky as possible, which means run as slowly as possible. And then the last thing we need to do is actually change the Gatsby build command. So we need to add this flag, which is this tells Gatsby what configuration file to use for the open tracing. And then we have a flag for GraphQL tracing as well. So you can include that or not include it, depending on your use case. But we're going to add it here. Okay, so that looks like it's installed. Everything looks ready to go. Just double check our config. Okay, so I think we're ready to go. And now we just need to run npm run build. And this should run our Gatsby build command. Okay, that's good. That's a very good sign. And you'll see these errors as well, but they're actually intentional. So one of the things we wanted to show, because we're collecting logs as well, is logs to the console, particularly errors, because these errors might not fail the build, but they'll certainly add to the build time. So we want to make sure that we see all of those things and are able to see them without having to look through the terminal. Okay, so while that builds, what we're going to do next is use New Relic IO, which is our brand new feature, which basically allows you to install pre-built dashboards and alerts for specific needs. So in this case, we have one for Gatsby build that we've built specifically. So this just basically installs a pre-built dashboard that we made just to show you all the kind of important information that you might need from a Gatsby build and get you started on kind of seeing and visualizing that data. So let's just click into here. I'll go through that again as I was talking over it. Okay. So we'll close this. So what we want to do in the new Relic 1 UI is up here at the top, you'll see Instant Observability. If we click on that, and then we should see Gatsby build here as one of the top entries, but you can also search for it here. So all we need to do is click. Let's just check if this build is. Yes, it's still working. Very good. So what we want to do is click install this quick start. So because we've already done this step, normally if you come here, it will take you to the instructions for actually setting up the plugin. But we've already done that, so we can either click done or skip this step. And what this will do is automatically add a Gatsby build dashboard to our new Relic 1 account, which is really cool. And I'm not going to click see your data just yet until this build is done. Otherwise, the big reveal will be ruined. One other thing that I wanted to point out is, so all of these plugins are what's, as part of the build, Gatsby is calling to perform certain actions, whether it's like transform images, style components, things like that, change MDX or convert MDX to other formats. These are all the things that are generating data as part of the build. And this is all the data that we're collecting and sending to New Relic. So it's really valuable data in itself. But when you compare that across builds to when you've changed something or added a new plugin or something like that, that's where it really becomes so valuable, because you can use that data to determine whether you should make a change, what changes you should prioritize, and things like that. So it's really, really valuable for stuff like that. Okay, we are getting there. So as part of the .env, we basically made it so that you just need to change some environment variables to either make the site slower or to speed it up. So to make it janky or to make it non-janky. You can also increase the amount of pages of products that we are creating to slow it down even more. And then we can also test scaling. I think that's one of the most important things for us in maintaining the doc site is, how do we scale? You know, like our Gatsby build times are already quite large, but if we wanted to scale, say we wanted to add another language to our doc site, so we wanted to add translate our docs into Korean, we have over 8,000 docs. So if we're going to double that, what effect is it going to have on the build time? That's really important for us to know. Okay, so this build looks like it's done. So now we click see your data, we should see the magic. Yes, okay, so this first tab should show us, it's got some other information if you want to follow on recommendations from Gatsby on how to optimize your build. We also have a Gatsby plugin, New Relic, that uses the New Relic browser agent to collect client-side data. And then you can also do lots of other things like install the infrastructure agent. But let's look at the build. So the hash here is basically just a unique identifier for each build. So we can compare that across different builds, but also across different data types. So like logs, metrics, and traces, we can say, okay, this build, we can see it across each one. So this is our overall build time. which is 170.96 seconds. When I do my second build, that data will be more valuable because it'll show the difference between each build, which is cool. And then here we have build times faceted by steps. So each step in the Gatsby build process, the bootstrap time, the instantiation time, benchmark start, things like that. This is where we see it all faceted. And again, when we do our second build, we should see a difference there and be able to just visualize, okay, that made it this much quicker, it made this much quicker. So it gives you like a general view of the build times, as well as allowing you to dive a little bit deeper into them. So let's just look a bit more at the APIs and plugins. Okay, so this is, this first chart is all of the plugins that are called by the Gatsby build process. As you can see, the on-post build is one of the longer processes. So this is average time, and the on-post build plugin is only called once. So that is like the total time for on-post build. But what we can actually do is not include that, and just to see how long on average each plugin took to complete. So we can see kind of the biggest contributors to build time. The same here with, oh, sorry, this is APIs. The same here with plugins. We can see that functions, the average duration for that took the longest, et cetera, et cetera. So it gives us a really good view on which plugins are taking the longest, which APIs are taking the longest. And then here we can also see, if we just dive into a little bit deeper in this chart, we can see the exact percentage of the total build time that the functions plugin took up. So you can also dive in here and change this to a different plugin. You could also look at an API. So it's really, there's lots of data there for you to do different things with and get lots of different information from. The same here, so the source node plugin API, took 0.129% of the overall build time. And then here we can also see our spans, but a better thing to do would be to go to the traces UI. So if you have an EU account, there is a separate link for that, but you can follow the link here in the dashboard. So if we look at the distributed tracing UI, we can see immediately that there were 50,000 spans on average as part of the overall Gatsby build. So that is a lot of data. That is a lot of API calls, a lot of plugin calls. And this allows us to visualize them as a waterfall, as an overall build, and step by step, exactly which plugins were called and when, which APIs were called and when as well. So lots of useful information there. Okay, let's go back to the logs. So this is a kind of just a general list of the latest log messages that have been outputted to the console. We collect all those up, send them to New Relic. We can see there's must be just some console logs that I was doing while I was testing something. And then also those errors. So we need to dive into those and see, okay, but this is creating an error. It's not failing the build, but it's important to follow up on those errors and see the impact of them. So we can actually, originally we built this and we were just looking at logs, and we could actually glean all of the build time information at a high level from the logs just by capturing them using regex from the actual log messages. So that's really cool as well. And that means you can also send any information. You could log anything to the console. It would send to New Relic, and then you could regex the information out of it if you wanted to. So really powerful functionality there. Then we can see there were 1.56 thousand information logs and 46 error logs. Let's just take a look at the logs UI. So we want to dive a little bit deeper into the errors, say. So we can say what attributes. Okay, let's see what level. I just want to see the errors. So there are 46 errors altogether. They all happened around here. And we can also look at those errors and see, okay, all of the metadata associated with them. So that's really useful as well. Let's go back to the dashboard and look at metrics. Again, the metrics will be, they're more valuable when we have multiple builds. So I'll go through them again once we do our second build. And then lastly, we have JS bundle size. So what we actually do is use the Gatsby plugin Webpack Bundle Analyzer v2, say that 10 times fast, to collect all of the information on your bundle size. So we collect gzip size, we collect stat size, and we collect parse size. So we could actually see if there are modules in our bundle that we're not using and that are taking up a large amount of space. Because bundle size is not only does it contribute to build time, because Gatsby is having to package it up, but it also affects on client side, it affects the user experience as well. So a lot of the improvements to build time will also have an effect on the end user, which is what we all want at the end of the day. So it's just cool to see all of this data come into New Relic and be able to visualize it as well. So what we're going to do as part of the second build as well is remove some unused, unneeded packages. So Faker will be the first one. And Gatsby source Contentful. So originally we were using Contentful, which is a CMS, to pull some data from, but we wanted to make this easy for people to use, so you wouldn't have to worry about API keys and things like that. Okay, so then what we're going to do is change this environment variable to false, so we don't want it to be janky anymore. If we have time at the end, we'll do a scaling build as well, just to show you the kind of difference between the builds. We want to do a Gatsby clean as well. We don't want to cheat. So just make sure that the cache is cleaned, because if the cache isn't cleaned, the build is going to be faster because it's using stuff that it's already built before and only recreating things that have been changed. And so then we run npm run build again. And this should be faster. I'll just take you through some of the changes we made as well. We followed some Gatsby guidelines as well. We were working with Gatsby when we wanted to move to Gatsby Cloud, and they gave lots of great recommendations on how we could speed up our build, code changes we could make, plugins we could change. So I've used kind of a couple of those recommendations here as well. So if we look at the Gatsby node, let's look at the important stuff. So the first change is just using a more efficient loop to create the nodes and to create the pages. So at the janky, we're just using a for loop, which can be a lot slower than using a map or something like that to perform those actions. We're also doing unneeded GraphQL queries is a big thing as well. It's like, so if you're creating a lot of pages and you're querying data that you don't need that you're not actually using in those pages, then that can really slow up your build time. So that's another thing we did, was just to add unnecessary attributes to our Gatsby build to creating, to the create page API. And then we've also just removed any unnecessary errors. So let's say we went in, okay, this is where that error is coming from. We fixed that. And then also removed some other unnecessary console logs that we may have put in while we were developing. Because if there are enough of them, they can add to the build time. So it's important to even just to clean up the console so that you can see clearly what's happening in the build and that nothing is going wrong. So I think this is looking like it's nearly done. It's getting there. Okay. Okay. Yeah, so Gatsby has lots of other recommendations for speeding up your build time as well. There is another thing we could do. Products. Okay, so another thing is that we're making this GraphQL query on each page when we're creating each product. So this is the individual products. Oh, sorry, this should be in here. Product single, yes. The individual products. But this can happen from time to time when you're developing. You add a certain thing, but forget to remove something else. So we're actually already adding this as context data into the page via the create page API. So essentially, we're querying the data here, and then we're querying it again when we're actually building the page. So we're double querying, and that would just slow down the build time a lot. So it's important to clean up those things, to identify them, and speed up your build. I also found this was a great way to kind of understand exactly what Gatsby build is doing. So it can be kind of mysterious when you first encounter Gatsby as to what exactly is happening during the build. And because I was new to the team when we started building this plugin, it was a great way for me to see exactly what Gatsby does under the surface, to peek behind the curtain. It was a really valuable experience, and try and get to know like what each plugin does, and what each API does, at what point in the build it does it as well. Just really gave me a well-rounded impression of how Gatsby works. So it's also valuable in that way, and all the data that we collect tells the story, and allows us to dive in and dig in a little bit deeper to see what's happening. Okay, so we already have a second build time, which is great. So we've actually improved the build time by 19 seconds. Sometimes it's more, sometimes it's less. Maybe because I'm streaming live, it's a little bit less than usual, but that's still a big improvement. That's I'm not even going to attempt to calculate the percentage, but it's quite a big percentage. And then, if you want to scale, that's obviously going to get even bigger and bigger. So you want to be able to reduce that build time as much as possible before you do things like scaling. So we can see here, let's just take a look at this. I'll actually refresh the page just to make sure that all the data has come in. Make sure the build is done. Yep. So it sends like different data at different points. It'll send like the metrics. It obviously sends each log as it's being logged. And then near the end, it'll send the metrics. And then at the very end, it will send the trace data. The reason for that is so that it doesn't affect the overall build time, because obviously collecting the trace data and sending HTTP requests for for that data to New Relic is going to add to your build time. So now that it does that all at the end, and it's not included in the overall build time, which is great. So we can already see here on the main page the difference in the timing of each step, which is great. So we can see that the post build was around the same time, but we can see that the pre-build was definitely shorter. The bootstrap time was shorter, and the instantiation time was shorter, which is great. So we can see like what those changes, the difference they've made to the different steps and the overall build time. So yeah, so let's talk about metrics. So first of all, we're collecting like several different types of metrics, and the plan is to be able to collect a lot more. But at the moment, we have collecting things like the amount of images you have and the different types of images that are on your website. That is good information to know, and the amount of MDX files as well. It is okay information to know by itself, but the best thing about this is that you can correlate an increase in images to increases in other things. So for example, if you wanted to add a lot more images to your site, you need to be able to tell what effect that's going to have on the build time. You can also see, okay, am I using too many, less, too many types of images that are kind of less good for web apps, if you will. So we can also see here, we collect some memory data as well from the local machine, which is cool. So we could actually see that the second build, there was an increase in memory heap usage, but there was also an increase in memory heap total. So maybe there's some correlation there. But we can track the data and see what an increase in certain things, what effect they will have on our memory consumption, and also across the other data points as well. So what effect this has on the bundle size, what effect the bundle size has on the memory, what effect all my logs have on the memory, and things like that. So it's a really good view right across your entire build to see those changes. And then, so we're able to see that the unneeded modules are removed. So you can kind of keep an eye on the overall bundle size. Obviously, you want to monitor that and see if it's, if it's increased in size suddenly. You want to take a look at why it might have increased in size, just to keep on top of it, which is great. Now, so let's see if we can do a third build if we have time. So I'm not going to I'll reduce the number of pages just to, oh no, actually won't, because that'll affect our build times. So if we say 5 here, but you can try this out yourself if you like, just by going to the repo that I linked, and you can kind of mess around with it. You can mess around with the data as well. We're basically, okay, I'm actually going to do a non-Gatsby cleaned build, just so we can see, because this will also tell us like the difference between when the cache is cleared and when it's not cleared. So kind of the improvements that you can get from like later versions of Gatsby, some of the functionality that they have in Gatsby Cloud for like caching and things like that. So it's a really useful thing to do. now. Okay, we can already see that this is a lot quicker. It's already gotten to on post build. Which you can see what I should have done there is add an extra Oh, did we lose audio? Perhaps. Can you hear me now? Ah, great. Okay, thanks. Sorry about that. Yeah, my Gatsby build broke my computer, so that means I need to make a lot of improvements. But yeah, so this will tell us like lots of useful information, like the author of the latest commit hash, commit timestamp, things like that. So you can like track changes in the application back to specific commits in GitHub, which is really useful because it's not always obvious what changes to the code introduced longer build times or shorter build times. So this is a really good way of tracking that back into GitHub and seeing exactly what changes were made. So lots of information there. And we're always looking to improve the plugin as well. So any other contributions even, the plugin is obviously open source, which is amazing. So any contributions from the public are very welcome. Yeah, so let's see what our third build did if it's finished. Let's just see, maybe my computer crashing. Oh no, it worked. Okay, so we can see that it more than halved the build time, if you include caching. So that's really great to see, really good to visualize and to track your different builds. So I think that is all from me. If there are no questions, if anyone has any questions, just pop them in the chat.